Good morning. Today we will discuss ROM, that is read-only memory. From what we call discussing about the computer, we have already learned when from the youngest age onwards, we have learned what is the difference between RAM and ROM. That is, one is random access memory and other one is read-only memory. And what's the difference? And also one is static, one is dynamic. That is the one which when the one in which the data will be erased when power is turned off, that is RAM. And also in the case of when we compare that with ROM, here the data will not be erased when the power is turned off. Okay, so such concepts that we have already learned, today we will discuss what is ROM and what are the different types of ROM. Okay, and discussing about it, we will go what we call, we will go in the details of what we call ROM. Okay, each kinds of ROM. So a memory device in which the binary information is stored, that is that read-only memory or ROM is a memory device in which the binary information is stored. The binary information must be specified by the designer and is then embedded in it to form the required interconnection pattern. Or in short, the designer is the one who decides what sort of information is to be stored in this particular ROM. Okay, so once the pattern or the data is established, this is very important. Once the pattern is established, it stays within the unit when the power is turned off and on again. This is something which is to be noted. Okay, that's a specialty. Don't get confused with such statements like specified by the designer and is then embedded in the unit to form the required interconnection pattern. Okay, in simple words, we can say that if the data is stored based on the pattern that the designer has designed for it, okay, that particular data will stay within the unit with the power if the power is turned off or on again. Okay, as the name suggests, it is meant only for reading the information from it. That is, it's read-only memory. We can read the data, whatever is stored in that particular ROM, but we can't write anything into it. Okay, a ROM which is programmable is called PROM. We will discuss about PROM in the coming session. That is, PROM is actually programmable read-only memory. Okay, so a ROM which is programmable is called PROM. The process of entering information in a ROM is known as programming. And ROMs can be used for programming combinational logic circuits. Okay, please go through. This is the block diagram or the ROM. We can also call it as a ROM organization. Just call that, it's just understand that it's the block diagram. Okay, in the block diagram, we can see there is a 2 raised to k into n ROM. Okay, and you can also see that there is the k inputs, that is the address, and n outputs, that is data. Normally, when we give a set of data, we get the corresponding or the changed data or the manipulated data, or what we call in many of the combination circuits that we have already seen, when we give a set of data, the output will also be data. Okay, but here we need to understand that ROM is actually a device, a memory element, where we don't give input, or the data will not be given as input to the particular circuit. Okay, as there is no write operation in it. Whatever is stored in it or whatever is programmed into the ROM, it can be read. That's it. Okay, so understand what is the concepts. It consists of, or the ROM consists of k inputs and n outputs. What is the speciality of this k and n? It's already written. The inputs provide the address for the memory. Okay, that is k inputs will be memory, the address of memory, and the outputs give the data bits of the stored word which is selected by the address. Okay, by using this particular address, we get a location in the memory. Okay, and the outputs give the data bits of the stored word. The output will be the data stored in that particular case. Okay, The number of words in a ROM is determined from the fact that k address input lines are needed to specify 2 raised to k words. Okay, I think it's clear to you. I will explain once again. The inputs provide the address, okay, for the memory, which memory is to be selected, and the outputs give the data bits of the stored word, which is selected by the address. Okay, please. As you all know, every system or every memory unit or any circuit has its own advantages and disadvantages. So we will discuss what are the different advantages and disadvantages of ROM. Okay. The ease of design, since no simplification or minimization of logic function is required. Actually, for the design part, when we consider the design part of ROM, we don't go for minimization using Karnaugh map or something. I mean, or circuits like or minimization techniques like that. We will directly plot and what we call form the table and directly construct the ROM. Okay. So there is no, it is easy, the design is very easy as there is no simplification or minimization of logic circuits. Designs can be changed, modified rapidly according to users' needs. It is usually faster than the discrete MSI bar SSI circuit. This is MSI means small scale integration, MSI means medium scale integration, SSI means small scale integration. Okay. So, what is it is actually a method of forming or what we call ICs or integrated circuits. Okay, method of forming integrated circuits. Here, actually, what happens is in SSI we use almost 1 to 10 transistors, and we also have almost in the range of 1 to 10 transistors, and in the case of SSI in the case of SSI we have 1 to 10 transistors, and also we may have what we call about 10 logic gates. Okay, and in the case of medium scale integration we use in a range of 1 to 100 what we call transistors. Okay, and this is also a method of developing ICs. Okay, so it's faster than discrete MSI or SSI circuits, and the cost is also low. The disadvantage is that the non-utilization of complete circuit. At times a ROM may be constructed with so many features, but all those features may not be used for a particular case. Okay, increased power requirement. Third one is enormous increase in size with increase in number of input variables, making it impractical. Sometimes it's just the opposite. Sometimes the complete circuit may not be required. This means as the size increases, the number of variables increases, it makes the circuit impractical to be formed. Okay, it making it impractical. Please go through.